Right, hello and welcome to Integration by Inspection. Okay, in the textbook, this is section 4, it's called the reverse chain rule, but I call it by inspection. The reason is because you need to be able to look at an actual integral question and know instinctively what the answer is going to be, or know instinctively what form the answer will take. It's really important. Okay, so a lot of standard integral questions are integrate this, and then with just 30 seconds thinking, maybe you know what the answer is straight away. Okay, and there are a lot of these different types of questions. I'm just going to take you through a few of them. You'll see why it's called the reverse chain rule when we're doing these, but I'd just like to get on with the actual questions. Okay, so the first one I've got for you is 2x over x squared plus 1. This is actually the same as one of those in the textbook. I believe it's example 8a. Okay, I'm not going to do the same questions all of the time for these. Some of them will vary a little bit, and I'm going to offer a little bit more as well, because I think just doing one of each type sometimes is never really enough. Okay, right, so what we're going to do with this one. Okay, well, if you recall from some of the earlier integral videos, okay, we've been integrating fractions, and what I've been asked you to look for is whether the denominator is effectively something to the power of 1. I've been saying a linear term for the time being. This term isn't quite linear, but if you consider it as x squared plus 1 to the power of 1, it's almost like a linear term. It's certainly something to the power of negative 1. Okay, so you could actually write that denominator like this: x squared plus 1 to the power of negative 1. When that happens, quite often you do get a natural logarithm as an answer. There's a little bit more to it than that though, but can you just go with it for the moment? Just go with it and think, okay, the answer is going to be something to do with natural log of x squared plus 1. Now, that's all I'm asking for the time being, because a lot of integral questions, sometimes you will not know straight away what the answer is. But I'm hoping you'll know what form the answer will take. That's all you need. Okay? As long as you know what form the answer will take, that's all you need to try and refine your answer and get closer to the answer. Okay? So let's just assume we've got y equals natural log of x squared plus 1. Let's differentiate that. Okay, so hopefully you can do this fairly quickly. Denominator x squared plus 1, differentiate what's in the brackets, you get 2x, and isn't that fantastic? Look at that. That is where the 2x has come from. Okay, so we've got precisely what we needed. So what that means is our initial thought was correct. Okay, it is natural log of x squared plus 1. Let's just finish it off by putting in the plus c. Okay, now why did that work? Why did that work? Okay, let me ask you a question. Okay, suppose instead the question was this. Let me just write it up. Suppose instead the question was integral of 1, say, over x squared plus 1 dx. I'm hoping you can see that the answer is obviously not going to be the same. Okay, because the integral of this on the left cannot be the same as the integral of that on the right. Okay, well, what's happening is, if you assume that your answer is this, what I'm highlighting, if you assume your answer is that, it's going to be wrong, isn't it? Because when you differentiate that, you get the 2x. Okay, the fact of the matter is the numerator is extremely important. Okay, numerator is extremely important. You need to check out what that is before you actually commit to what the answer is. Okay. The actual integral of 1 over x squared plus 1 is rather more difficult. You can ask someone who does further maths, or you can look it up. Okay, should be quite easy to find on the internet somewhere. Okay, but I'm not going to go over it now. It is further maths only. Okay, so what I'm going to leave you with for the time being is that the numerator is really important. Okay, there's a general rule which I'm going to discuss after the next example, and here is the next example. Right. What you need to do is just look at it. Okay, same with all questions. Okay, but with integrals in particular, just look at it and think, right, what have we got? We've got a fraction. Okay, let's just remember what Mr. Brown said earlier, the denominator. Okay, can we write that as x cubed plus 1 to the power of negative 1? Yes, you can. Okay, now the consequence of that is, what I'm saying is, if this denominator was something all squared or cubed, then no, it's definitely not a natural logarithm. Remember, natural logs work only when it's in the form integral 1 over x. Okay, if it's not in the form 1 over x and the power on the bottom has got to be just a single power of 1, then it's not going to be a natural logarithm. What you want to do is just check out what the numerator is. I'm hoping some of you are quickly picking this up. Okay, well, let's just go with an answer of natural log of x cubed plus 1 for the time being. Okay, and we just differentiate that and just check out what the answer is. Okay, so numerator, we'll check in a minute. Denominator, x cubed plus 1. Now if we differentiate what's in the brackets, you get 3x squared. We are really close. We are really close, aren't we? Because we've got x squared that we want instead of 3x squared. Okay, well, that is no problem. Okay, we're just going to multiply that answer by a third, which means you're going to multiply this by a third as well. Okay, so our answer is going to be simply 1/3 natural log of x cubed plus 1. But we got it through trying the natural log as an answer. Now, just pretend I choose a different question and I choose this instead. X over x cubed plus 1. Would you still get a natural log as an answer? I'll pause for you to think about it. You should pause the video until you got the answer. Okay, welcome back. Hopefully that was a long pause or a short pause, but hopefully welcome back anyway. No, you're not going to get the same. The reason is, if you look at the working we did all the way over here, okay? Thing is, when you differentiate what's in the brackets here, you're going to get an x squared term. There's no way around it. You are going to end up with an x squared term. Okay, and so no, your answer is not as simple as that. Okay, so what you're looking for is the denominator and the numerator. They are linked together. Now I'm going to pause there. You should pause the video, and I want you to have a think about what the general rule is. That is, when you've got a fraction that you want to integrate, what is the general rule relating to the numerator and denominator? Right, pause the video. Right, welcome back. Well, hopefully, welcome back everybody. Okay, maybe some of you are switched off. Okay, and don't want to know the answer. In which case, good luck with your exams, folks. Okay, but those of you who are sensible enough to find out what the answer is, let's just discuss it. Okay, so suppose you want to integrate a fraction. Okay, and you're given a numerator and denominator. Okay, the answer is, if you differentiate the denominator and get the numerator exactly, that is your classic case of your answer is the natural log of the denominator, and that is a really important result. Okay, that is, if you have a fraction, if you differentiate the denominator and you get perfectly the numerator, then your answer is the natural logarithm of the denominator. Okay, just remember why that is. Okay, and it's easily to show. So natural log of f of x, if that is equal to y, dy dx, you know the denominator already is going to be 1 over f of x. Then this is the chain rule bit, you see. You differentiate what's in the brackets, you get f dash x. You see how that works? Okay, and that's why this section is called the reverse chain rule. You need to know that. Okay? You need to know that when you differentiate an expression like this using the chain rule, you're going to get this answer. You need to know that the reverse of that means when you integrate f dash x over f of x, then you're going to get the natural logarithm of f of x. Okay, so the reverse chain rule basically means you need to know what a lot of results are when you differentiate them. Okay, what the derivative of lots of results are. And that's why I call them inspection questions, because you've got to be able to instinctively look at an integral question and know what is going on in reverse. It is really challenging. It means you have to know differentiation almost inside out. Okay, you need to be really good at differentiation to be really good at integration, and that's why integrals are a lot harder. Okay, differentiation by contrast is easy. You've got product rule, you've got quotient rule, okay, and you've got chain rule obviously, but with integration it don't always work that way. Sometimes you need to know what the result is in reverse. Okay, if you need to look at that again, then do so. Okay, I suggest that when you're revising for your exams, you look at this video again. Okay, because that is a really important result. Right, let's have a look at another question. Right, integral sine x over 4 plus 2 cos x. Okay, now if you choose, you can pause the video and you can just work it out. Okay, Normally what I do in class, you see, is I put it up, there it is on the board, and I'll say, right, you've got a few minutes to work it out. Okay, a few minutes is generous. Okay, hopefully you either pause the video or you just want to continue on and listen to my lovely voice. Okay, I'll tell you what, not all students that I've ever taught thought my voice was lovely. As a large section of students that thought my voice was evil. Do you know, once I was asked to do a voiceover, so I'm going off, but yeah, this is what I do in lessons, isn't it? Okay, I'm just trying to make it a bit more realistic. Sometimes I go off on a slight tangent. Okay, and yeah, there was almost a pun there, wasn't there? If this was differentiation, tangent would be a wonderful pun. Okay, but anyway, what I'm trying to do is I'm just trying to integrate humour with calculus. There you are, that's my pun for the day. Yeah, I was asked to do a voiceover. Okay, a voiceover for a video game that somebody was making. Okay, and I was asked to say a line, and I said it, and at the end I said, so why did you choose me? I'm not someone who does drama, obviously, I'm just a maths teacher. Why did you choose me to do voiceover? And he said, well, please don't take this the wrong way, sir, but you've got kind of an evil voice. Okay, thanks, great. Anyway, that was it, wasn't it? There's a whole load of students who thought that I had an evil voice. Okay. Anyway, if you're one of those ex-students who's now in their 20s or even 30s, hello. Maybe you're finding my voice just as evil. Okay. But anyway, no harm intended. Okay. I act professionally at all times, I hope, or most of the time. Anyway, let's get back to the integration, shall we? Okay, sorry for the short pause. Okay, but I did say that some of these I'm trying to do in the same style that I do my general lessons. Okay, right, we need to integrate this bad boy, don't we? Sorry, it's a bit of Alan Partridge, wasn't it? I'll lose myself when I'm on my own. Look at the denominator. Okay, when you differentiate the denominator, let's just write it down. Okay, you're going to get negative 2 sine x. Okay, what we're after is some multiple of that on the numerator, and yes, we do have that. We've got a multiple of negative 2 sine x. We've got sine x on the numerator. What that means is straight away you can write down that the answer must look like this. Okay, natural log of 4 plus 2 cos x. Okay, because let's just write down over here, when you write down natural log of 4 plus 2 cos x, when you differentiate that dy dx, you're going to get something over 4 plus 2 cos x, and because of the chain rule, you're going to get negative 2 sine x. Okay, and so you can see if you just multiply that by negative a half, multiply this by negative a half, your answer is going to be negative a half natural log of 4 plus 2 cos x plus c. Done. Okay. I'm going to leave that video there because those are the examples I had on the natural logarithms. Okay. What I will do is I'll post another video as soon as I've recorded it, that is, on some further examples of inspection questions. But that's it for the time being with inspection. Right. Hope you enjoyed that one. I'll see you later.